Hi everyone, this side Manisha Mishra, Assistant Professor in Mathematics, Applied Science Department at St. Andrews Institute of Technology and Management, Gurgaon. This college is affiliated to MU, means Maharshi Dayanand University, Rohtak. And today's topic, contour integration, multivariable calculus. So first, contour integration I will discuss inside Cauchy-Gertz theorem, zeros, poles, singularity, Cauchy integral theorem, etc. So first, before starting contour integration, I just want to tell you what is line integral in complex number. So first, we have already no line integral in calculus, means for f into dr vector, but in complex integration, what is your line integral? So line integral, that means single integration. So single integration a to b fz dz, because we are studying complex integration, so our line integral in the form of z. So z is a complex variable, and a to b fz dz, any curve from z is equal to a to z is equal to b. So z is equal to x plus iota y, we know that z is equal to x plus iota y, and dz is equal to dx plus iota dy, and x is your horizontal axis, y is your vertical axis. So just put the value of fz and dz in our line integral. So first one, we have two axes, that means we along x-axis your y is equal to 0, and along y-axis your x is equal to 0. So first, now along the line y is equal to 0, that means along the curve x, means horizontal axis. So y is equal to 0, that means dy is equal to 0, so dz is equal to dx only. Now along the line x is equal to 0, your dx will be 0, so dz is equal to iota dy. If fz is given u plus iota v, we have already know this, fz is equal to u plus iota v. So just to and dz is equal to dx plus iota dy, so just find your line integral a to b fz dz is equal to a to b u plus iota v dot dx plus iota dy. So a to b u dx plus iota v dx and iota u dy, just iota square v dy. So just find the value of write the value of iota square here, and consider real term one side and write just imaginary term another side. So your real term is a to b u dx minus v dy plus iota v dx plus u dy. So this is your real term and this is your another term. Now next one is, there is a question here. We know that z is equal to x plus iota y, so z bar is your x minus iota y. So there is a question related to line integral. Evaluate 0 to 2 plus iota z bar whole square dz along the real axis from z is equal to 0 to z is equal to 2, and then along a line parallel to y-axis from z is equal to 2 to z is equal to 2 plus iota. So first one, given curve is your 0 to 2 plus iota. So and just check your reason is given z is equal to 0 to z is equal to 2. So 0 to 2 plus iota z bar whole square dz is equal to 0 to 2 plus iota x minus iy whole square. As we know, z bar is equal to x minus iy. So just write the value of z minus z bar here and write the value of dz here. Just solve, and after just calculate each and everything. X is a plus b, a minus b whole square will be open here, and find the product of these two brackets. Then limit is given, z is equal to 0 and z is equal to 2 plus iota. To solve this line integral, we need to find our limit. So limit is given in the form of z, and lower limit is given z is equal to 0. This one is called lower limit, this one is called upper limit. So z is equal to 0 is your lower limit. So you can write z is equal to x plus iota y and 0 plus 0 dot I. So you will get your lower limit in the term of x and y, 0 and 0. Now z is given 2 plus iota, so x plus iota y is equal to 2 plus iota. Then you will compare on both sides. So on comparing both sides, then you will get x is equal to 2 and y is equal to 1. Now next thing is, just you will draw a figure here along the line. The reason is given, question is saying that along the line x is equal, z is equal to 0 to z is equal to 2. That means you will find your curve along the line x is equal to 0, y is equal to 0, x is equal to 2. So the curve is this one. So along the line y is equal to 0. So along the line y is equal to 0 means lie on x axis. Along the line y x is equal to 0 means lie on y axis. And along the line x is equal to 2. That means z is equal to 0 and only x is yeah, z is equal to 2 means x is equal to 2 line. So this line will cover your final reason. So you will find your reason only along this line and on, along x is equal to 2 line. So along the line y is equal to 0, so you will get dy is equal to 0 because, and x varies from 0 to 2. So it is coming from your figure. Just look at here. At y is equal to 0, so your initial value here x is equal to 0 and x is moving 0 to till x is equal to 2, and this is a boundary. Boundary is your x is equal to 2. So limit your 0 to 2 and y is equal to 0. That means dy is equal to 0. Now put the all values in your upper above integral. So 0 to 2 x square minus 0 dot dx plus 0 dot iota. So 0 to 2 x square dx, there is your final answer. X square integration x cube by 3, limit, just apply the limit. So upper limit 2 cube minus lower limit 0. So 2 cube minus 0 means 8 by 3. Now second, along the line AB. What is your AB line? AB line is your this one, AB. Along the line x is equal to 2. So along the line x is equal to 2. That means you will put x is equal to 2 near in above integral, this integral. Now find dy. So x is moving, y is moving 0 to 1. So your limit is 0 to 1 and x is equal to 2. So dx is equal to 0 and y varies from 0 to 1 because x line is moving 0 to 1. Now just put the value in the above integral. So 0 to 1, 4 minus y square minus 4 iota y, and dx is 0, so 0 plus iota dy. Now solve this integral, just integrating with respect to y, and separate all these three parts and integrate all these things, all the part, then you will get your final answer 11 by 3 minus 2I into iota. So this is the this is along the line AB and above along the line OA. So just total integration, your total line integral 0 to 2 plus iota z bar whole square dz is equal to 8 by 3 plus 11 by 3 minus 2I into I. You can multiply by iota or write as it is. So this is your just little explanation of your line integral. Now next is your zeros of an analytic function. Before starting your contour integration or Cauchy-Gaussian theorem and Cauchy integral theorem, I just want to tell you zeros of an analytic function. So before zeros, I will discuss a little point, multi-valued function. So multi-valued function means more than one function. Before zeros, just see multi-valued function. So multi-valued function, that means there will be arise one more than function, more than one function. So what is your multi-connected reason? Multi-connected reason means you are connected with more than one reason. So multi-connected reason is bounded by more than one curve. We can convert a multi-connected reason into a simply connected one. That means you are converting a reason into a more than one curve. So this is your multi-connected reason. Now next point is your single valued and multi-valued function. So as I told you that single valued function, that means only one variable will be here, and multi-valued function, that means more than one variable. If suppose you have fz is equal to z square, so this is your single valued function. This is your single valued function. Now if we saying that your multi-valued function, so if a function has more than one value, so it is called multi-valued function. Suppose fz is equal to square root of z. So square root of z, that means there can be 2 point something something, whatever you are taking the value of z. So this is your multi-valued function. Now next point is your multiple point. If an equation is satisfied by more than one value of the variable in the given range, then the point is called multiple point of the arc. Multiple point definition, that means suppose if you have fz is equal to z square, and you put the value of z is equal to 2, then that means 2 square. So 2 is a 2 square value is 4, and you are putting the value of z minus 2, then you will also get a value of minus 4 positive value. So we can say that this is a multiple point function. Now next topic is your zeros of an analytic function. So zeros of an analytic function, that means the function which satisfied the CR equation, or the CR equation, and function can be differentiable. So zeros, what is zeros? So zeros is nothing but the value of z for which the analytic function fz becomes 0 is said to be the zero of your fz. Basically the meaning of this line is that we can put our numerator is equal to 0, and that if you are putting numerator is equal to 0, that means you will get your zeros. Put denominator for zeros, put denominator is equal to 0, so you will get your zeros by the solve that equation. Now next is zeros of an analytic function. Sorry, there is an example here. Z square minus 3z plus 2 plus of dz is equal to 0. So put for zeros of fz, put fz is equal to 0. So numerator is equal to 0, so there because there is no denominator, so you can write just fz. So fz is equal to 0, so z square minus 3z plus 2 is equal to 0. Z square, just solve, this is a quadratic equation, then you will get 2.2. Z is equal to 1 and z is equal to 2 are zeros of fz. So this is the example of your zeros. Now there is another example. Z square minus 1 upon z square plus 4 of dz. So just for zeros you will put fz is equal to 0 here. So z square minus 1 is equal to 0. Z square is equal to 1, so z is equal to plus minus 1. So 1 and minus 1 are the zeros of fz. Now there is another point, pole. So poles of an analytic function. So pole is a part of singularity. We will discuss the topic singularity further, but now pole. So to find the poles of an integral, put denominator is equal to 0. For zeros we will put numerator is equal to 0. For poles we will put denominator is equal to 0. So there is an integral here, fz upon z minus a whole square dz. So just put the denominator is equal to 0. So z is equal to a, and a is a pole of order 2 because it is 2 times. So this is a pole of order 2. Now there is another example here. Put z e to the power z minus a upon z cube dz. So put the z cube is equal to 0. So z is equal to 0, 0, 0 is a pole of order 3 because it is coming 3 times. And that is the third example, z square upon z minus 8, z minus b, z minus c. So just put denominator is equal to 0. So z is equal to a, b, c is a pole of order 1 because a is coming one time, b is also one time, c is also one time. So this is called pole of order 1. And pole of order 1 is called a simple pole. A simple pole means pole of order 1. Pole of order 1 means simple pole. So I think zeros and poles topic can be asked in your exam, like define zeros with example, define pole with example. So just you guys try to learn this topic. And next video I will share a contour integral topic with Cauchy-Gaussert theorem and Cauchy integral theorem. So I hope you will like this video. Thank you.